In section 4, we take a look at inscribed angles. If you remember earlier in a different section, we talked about central angles. There's a difference between what is a central angle and an inscribed angle. So we're going to first start by finding measures of inscribed angles, and then we'll look at finding measures of inscribed polygons as well, specifically quadrilaterals and triangles. So first off, what is an inscribed angle? Well, an inscribed angle goes or has a vertex at the edge of the circle. So point R would be considered the vertex. Notice how it's on the edge of the circle and its other 2 points are also on the edge of the circle. Looks different than what the central angle looks like. So if I try and draw, it's going to be pretty bad. This would be considered a central angle. Notice that it's at the center of the circle. An inscribed angle is going to go to the edge of the circle. This one in here would be considered the inscribed angle. So there is a difference. But there is a relationship between both parts, between an inscribed angle and a central angle. And if I come down here, that relationship is this inscribed angle, angle 1, is half of this arc. Remember, this arc would be the same as its central angle. So arc AB in here is going to be, if I go backwards, arc AB would be double my inscribed angle. Okay, so just to show you and reiterate this relationship, here would be an inscribed angle, a central angle, and its arc. You can see that the inscribed angle down here is 42.01 degrees. I tried to get it close to an exact value. Its angle measures 42.01. Notice that the arc and its central angle have the exact same measure. We talked about that. A central angle and its arc should have the same measure. But notice the relationship between the inscribed angle and the arc. The inscribed angle is exactly half of 84.02, right, or that arc measure. Okay, so keep that in mind. Let's try a couple problems. I have a whole bunch that show this relationship. So let's look at letter A up here. I want to find the measure of angle P. Well, sometimes it actually helps to draw in where is angle P. Angle P comes off of this relationship. So the angle measure that I'm worried about is 70. Remember, angle P, that's your inscribed angle. It's half of the arc. So 70 divided by 2 gets us 35 degrees. Letter B, now I want to find the measure of arc PO. So now I'm going to find that arc. Remember, since I'm talking about PO, I want the shortest distance. I want that arc, and it comes off of that angle measure. Well, since I'm going from an inscribed angle now to its arc, I'm going to double 56. Take 56 times 2 should get me 112 degrees. We've got a couple more. Let's do these down here at the bottom as well. I want to find the measure of arc CF. I'm going to find CF, draw in its angle. There's the angle measure that I'm dealing with. Since I want the arc, it's double the inscribed angle. Double 40 gets me 80 degrees. And then the last one, I want to find the measure of angle C, which is right there. Really, they should label that maybe just a little differently. Maybe DCE would be better. But I want to find that measure. I'm going to draw it in. Now I'm going from the arc to the inscribed angle. Half of 98 would be 49 degrees. Oops, now my pen's not writing, but it should be 49 degrees.